Landen's identity for dilogarithm function proof. So basically in this video we will prove this identity, and I do think that you know about dilogarithm functions. Basically I have made all the introductory videos on this function in my YouTube channel. Yeah, basically you can check the playlist over here where I have introduced it from the basic and also proved other identities like inversion formula. Yeah, in my previous video I proved the inversion formula, that Li2 of z plus Li2 of 1 by z, this is actually equals to minus Riemann zeta of 2 minus 1 by 2 ln square of minus z. I have also proved the reflection formula, that Li2 of z plus Li2 of 1 minus z, this is actually equal to Riemann zeta of 2 minus ln of z ln of 1 minus z. You can check these proofs and then you can come back to this later on, so that basically the idea I have used in the simpler proofs is what I will use in this proof too. So basically it will kind of give an idea on how we solve this problem if you go through these proofs. Yeah. So basically after you have, let's now solve let's now prove this identity too. Okay. So basically to solve this to prove this identity we are going to use Leibniz rule, yeah, which states that, let's say if I have a derivative of f of x, and if I'm integrating this from 0 to x, I will just basically get f of x itself. So basically now what we will do is we will basically try to take f of x as g by 1 plus g, yeah, and then also take the other expression where it's differentiated and integrated, and surprisingly we get a really different expression after differentiating and integrating, and both of them should be equal. Yeah, yeah. So okay, so we will basically mm, get a different expression on the, in the different expression we will get from this operation is basically uh, minus Li2 of minus g minus 1 by 2 log square g plus 1. We will get this result. Yeah. And now after we get this result, we can just take the Li2 of minus g to other side, and then we'll prove the identity. But let us see like how do we get this result from this thing. Uh, First of all, let's just differentiate this. If we differentiate the Li2 of g by 1 plus g, we know that its derivative is minus ln of 1 minus t by t, yeah. So we get minus ln of 1 minus g by 1 plus g by g by 1 plus g, and then derivative of this thing is, okay, so 1 plus g times 1 minus g times 1 by 1 plus g, so 1 by 1 plus g. So you can basically use the quotient rule to get this identity. Now this over here minus ln of it is 1 plus g minus g, so 1 by 1 plus g by, now this is 1 plus g cancels out, so we have g times 1 plus g. Okay, now you might see that it's simplifying a lot. So now using this, okay, using the property of log, we can write this as ln of 1 plus g, and now this can be broken down into partial fractions, 1 by z minus 1 by 1 plus g. Yeah. Okay, so now this is the derivative. Now let's integrate this. Yeah, so basically now let's integrate this to get the original function. So Li2 of z by 1 plus z, to get this we now have to integrate this from 0 to x itself. Yeah. And so I have ln of 1 plus z 1 by g minus 1 by 1 plus g, and let me write this in terms of t for now, and then write it over here as z, because at last I want to take it in the world of z. Yeah, that's why 1 by t, 1 by t, okay, and then dt. Okay, now how do we integrate this? That is the problem. Now for this integration we can basically, let us write this as different terms minus ln of 1 plus t by 1 plus t dt. Okay, so now if we integrate this, what will we get? So basically it's 1 minus t, and we can make over here minus t, and also in the differential d of minus t. Yeah, but we get this to be minus of li2 of minus t. Yeah, and evaluating at z we have minus z. Okay, minus, now if this is y, 1 by 1 plus t dt will be just dy, so we have y square by 2, so we have 1 by 2 ln square of 1 plus t. Now this thing is evaluated at 0 and z, only this thing, cause this is already evaluated from the definition. So we have minus li2 of minus z, and now this thing at z, this is ln square 1 plus z, and 0, this is ln of 1 square, that's also 0. So we have minus li2 of minus z minus 1 by 2 ln square 1 plus z. So you see, like I told that we are getting this expression, and we have now got it. Now this is just li2 of z by 1 plus z. Now you can take it to other side, sorry, and then we will have proved the identity. Now after this we have li2 of z by 1 plus z plus li2 of minus z is equals to minus 1 by 2 ln square of 1 plus z, and so this is proved. Yeah, so if we have to talk about the flow of the proof now, so basically I have also used the technique in the inversion formula in this one as well. For this one it was quite straightforward. Here also I used the same technique of differentiating and integrating. Yeah, and in the meantime we got different results over here, and then equating them we got the answer. So basically when differentiating, it got into somehow a different form, a simplified form, which could be easily integrated. And yeah, this was the proof for Landen's identity. Now you can use this identity to get different results. Yeah, and yeah, I will make some more videos where I will be using the results to solve problems. Hope to see you there. Thanks for watching. Look forward to seeing you in the upcoming videos too.